Once again, welcome all to the session on integrating Ansible automation platform with DevOps workflow. And we have Ginesh with us today to talk about it. He works at the Red Hats and as a platform and DevOps consult, and he have also written the book called Ansible for Real Life Automations, and he will be walking us through the topic and sharing his expertise. So let us hear from him. Over to you, Ginesh.
Thank you, Siraj. Hope my audio is clear.
Yes, it is.
Okay, great. Thank you all for joining, and thank you, Siraj and team, for having me here. Okay, so so today we have an interesting topic where we will be discussing about how we can use Ansible and Ansible automation platform within the DevOps workflow for automating the different operations in CI/CD, GitOps, or whatever the terms you are using inside. Um, so we have a very small agenda for today. We will be talking about the very high level introduction to the DevOps and automation and why we need to automate the things in DevOps workflow. Then we will just talk about Ansible and Ansible automation platform, some main components, and we will learn what are the possibilities for integrating the AAP in DevOps and your CI/CD GitOps workflow. And we will have a quick demo on how we can implement these in high level, and of course we will have a Q&A session. So yeah, we please keep the questions, and I think you can ask in chat or maybe at the end of the session. Yeah. Okay. No need to. It's just an intro. My name is Ginesh. Um, I work as a system engineer, an automation specialist, DevOps kind of thing, and I also contribute back to the community by blogs, videos, and all. And also, I wrote a book on Ansible for real life automation. That's it for now. Please connect with me. Okay, so this is our beginning of the session. Actually, we know this idea in high level, right? What is a software development? What are the SDLC life cycle phases, and which are the teams involved in these phases? Like we have analysis, design, development, testing, deployment, maintenance, and many other sections actually. So we know there are different teams and different individuals working on these topics or stages to improve and to make it like make the better and better products or software, right? um, so we know actually we have this IT, we have this infrastructure, we have this storage network, whatever. Actually the final goal is to host some application and serve it to the end user. It can be a website, it can be a mobile application, it can be some kind of application at the end. So there are a lot of unsung heroes behind the scene. So we can see, okay, developers develop the application, but there are many people like the infra ops. Then we have the cloud engineers. Then we have the storage team, network team. Even we are telling, okay, we are using cloud, and I can create my own VMs and instances and storage. Still, there are many people working behind, and they made it like a self-provisioning system. So it's a big ecosystem, right? So we are not talking about the infra storage kind of thing. We are just talking about the developer and the operator here. So we have this kind of issue every time. So we have a developer who developed the playbook, sorry, who developed the software. Then this software will be deployed somewhere and serve it as a application, right? Kind of a service. So developers are using their own infrastructure, their own laptop, their maybe a workstation, kind of a different environment, and they will not have much idea about the production infrastructure, like where it's hosted, what are the requirement, like what kind of traffic is coming. They will not have this kind of information or the kind of idea usually, and they really don't care about the production setup because their focus is on the application enhancement, performance, features, bug fixes, right? And on the other side, operators are focusing on the application uptime or your service uptime, and they worry about the changes. So whenever there is a change in the software, whenever there is a new version or some bug fix, the operator need to take care of the entire changes, deploying the new application to the servers or deploying new containers, or it can be any kind of operation, depends on your infrastructure. And always they worry about the infra changes, like when there is a new systems to be added to the cluster, or when there is a new storage to be added, kind of thing. So we have this kind of issue, like developers develop the software and they say, okay, it's working. But when we go to the production, it may not work because it's a different environment. We have to streamline it. So because the application meant to serve from a server, not from a workstation, right? Okay, now we have a better culture now, and we call it a DevOps. Okay, it's a culture. It's not a role. Yeah, of course we have a DevOps engineer kind of roles available. Again, when the developer and the operation team works together, we have a lot of benefits. First thing, developers and operators communicate transparently, so they have idea. Okay, what is happening? What is this? What is the infra side? What is the requirement for the infra in terms of in terms of the application? So they know better about the application now, and the software developers know, okay, this application is going to host on this kind of infrastructure. Okay, we need to take care of these items, like for example the memory the application is using, or the CPU requirement, and they can tell that operator, okay, I need this much memory or resource for this application. This kind of thing happen when developers and operators talk each other, and together they can implement a better and efficient software development workflow. Of course, the communication is important, and there should be a lot of tools to support this collaboration, communication, and of course automation. Okay, now this is a very high level definition. Like actually you can see different types of definitions for DevOps. Basically, it's a approach, it's a culture which include like automation, the platform designing, um, and many other things. But the final, our target is to deliver the software applications faster and efficient way, right? So it can be like it will help us to go to the market fast. It's like earlier we developed the software, then if there is a change, it will take weeks or months to deploy the new code to the production, because it's it will take a lot of time to redeploy the application and test it and make sure it's working, and it's working with the other part or other components of the software. It just think about a simple software like your taxi booking application or mobile banking application. There are like thousands of components involved, right? You have your bank account, then you have a payment, then we have different components inside. So each component should talk to each other well. And whenever there is a change, we have to ensure, okay, nothing breaks. So it's a kind of a very simple mashup of development and operations, but we know it represents a lot. Okay, it's ideas, culture, practice, and many more. Now, why we need DevOps? So it's very simple. Of course, we can reduce the risk because we can automate a lot of things. Then we can improve the quality because less human mistakes, and we can include a lot of automated tests, automated validations, and by which you can reduce the cost as well. Of course, the main or core components are main ideas are like continuous and automated testing. Then we try our best to develop and test the application in an environment similar to the production one. So we can say, okay, when it go to the production, it will work as per expectation. And of course, we should have an automated build and delivery system, like building the application or building the container or storing the software packages somewhere. Instead of someone log in and do it, we should have an automated system in place. Now, so this is another or a key component in a DevOps system. Like we should have a source control management or SCM. You can call it a source control management or version control management. There are different names and different level of features. It's a best practice for keeping your source code with an option to with a feature to track the changes. So whenever you make changes, let's say you have a software working, one of the button you want to make from green to blue. It's a simple change, but still you need to track it and make sure everything working. So if there is a issue with a new update, you should have an option to go back to the previous version. Source control management systems or this kind of softwares will help you to implement these. So we know there are some of the logos, maybe you are familiar with that. The Git servers, Gox, Git, some of them are open source and free. You can install on your laptop or on-premise servers. Some are enterprise and SaaS solutions. And like GitHub, you should have like a connection to the internet kind of thing. So this is very important because earlier days we keep the software somewhere as a files. Now we don't keep it as a files. It's more like uh, files under tracking. So whenever there is a change, it will be tracked using the branches, using the commits and all. So this is a simple screenshot from a Git repository where you can see there are changes happened by a user or developer, and you can see the details or the commit history, like okay, it was happened this, and if you click there, you will see okay what happened actually. Also you have an option to create multiple branches, and you can create different branches for it's a kind of a copy of the original one, but you can have a multiple, like for the development branch you can have a stable branch, you can have a feature branch, bug fix branch kind of thing, so that still you have a original copy which is working. So in case anything goes with okay version 2.12 is not working, you can simply go back to the 2.11 and get the working copy. So source control management is an important one. Okay. Now we talk about the CI/CD. So we have a CI/CD and another CD. So one is the continuous integration where you push the code, then it should be tested, validated, and merged to the main software repository. This is called the simple CI, which is continuous integration. Once you tested the code, you have to build the application. So it can be a jar file, it can be your a container image, it can be a Node.js based code, which will be stored to a central repository like artifacts or kind of a source control management, or it can be a container registry. This is a continuous delivery. And we have another CD, which is a continuous deployment, where the tools will take care of the deployment of the new application to the production system. So it will take care of the deploying a new container image, or it will take care of deploying the new software package on the target system by overwriting or cleaning up the existing folder kind of thing. This is called continuous deployment. And we have several tools available for doing this, including Jenkins, GitLab, GitHub Actions. Yeah, you know the logos already. Now, so we know the DevOps CI/CD thing. Now we know that it's like a big ecosystem. So we have a lot of tools available for uh, CI, building, testing, deploying. Even okay, if you have a GUI based software or application, still you have a lot of tools available for testing the GUI based uh, tests like integration test, regression test, or kind of thing like a Selenium and all already. Then for the building, many tools available like a Gradle, Maven, Grunt. Yeah, you can see the logos. Or now we will start with Ansible. So before we go to the Ansible, so what will happen when you push a code change? So something changes, right? Like you change the button from blue to green. Now, what should happen automatically? So this is a DevOps, like the infinity loop. So we have to plan the software, then we code the software. Like okay, we develop the code, then we scan for like vulnerabilities, like best practices and all. This one we can like static code analysis, and we have dynamic code analysis or different tools available. So whenever you push the code, we make sure okay, this code is clean and no issues. This is called a security shift to left actually. So instead of you monitor the application for vulnerabilities. You can test the application before you build and deploy. Then you have to build it, test it, then yeah, this is a kind of a continuous infinite loop. Integrate it, release it, then you test it, then deploy, operate, monitor. Yeah, it will be like that. So this is not going to end, because whenever there is an issue or something like a bug, then you will report it back, then you have to plan it again, code it again. Yeah, this is a flaw. This is like some other flaws or stages I just mentioned here. There might be many stages depending on your environment, depending on your organization workflow. Yeah. Now, where should I deploy the application, because it's already built and ready to use, right? So we have earlier we used the bare metal servers. Then bare metal servers like just one server, like when one machine. Then you deploy an operating system like Linux or Windows X or kind of thing. Then you have your operating system. Then you have your libraries, application, and so on. Now we have a new technology, not new now, uh, called virtualization. So we will have a hypervisor software like a VMware kind of thing. It can be VMware, it can be KVM, or it can be other hypervisors, Sen and all. And on top of that, you can create multiple virtual machines. So it will have its own operating system, libraries, and you can deploy application. So this is far better, because you can share the resources from a bare metal or physical server. Now it was good actually, but we have a new term coined called microservices, containers, and now we have this term called containers. So containers, it can be a virtual machine, it can be a physical server. Then you have installed the operating system. On top of that, you have a container engine. Then you have multiple containers for the application. Very simple. So you are again maximizing the utilization of your computing resources. So you know the terms like Docker, Podman, Kubernetes, Red Hat OpenShift, and all. So you have multiple options for deploying the applications, and you know the pain and you know the pros and cons for using different applications. Like if you're using virtualization, like if you're using AWS or Google Cloud, okay, you can create VM using automated way or manual way. Or if you're using the containers, we have different ways for deploying these application to the production container platforms like Kubernetes or OpenShift. Okay, this is a very high level. I think we still on time. Okay, good. Now, we have some more automated way of provisioning the infrastructure, which is called infrastructure as code, because everything is a code actually. So instead of creating the infrastructure manually, like going to the AWS console or going to the VMware console or going to the Azure console, you can use the IAC tools and provide the uh, code which contains the instruction to manage, create, and maintain the infrastructure like servers, storage, networks, security rules, policies, network, VPCs, kind of thing. This is the good thing, because you always have a single source of truth. Instead of going to the console and change it manually, or instead of using the CLI commands, you just change the code and update the infrastructure. What is a good thing? Something goes wrong, you can still go back to the previous version. But if you are creating it manually, then yeah, the rollback is not easy, because you have to delete it, you have to reconfigure it. But if you are using the IAC or infrastructure as code, the tool will take care of the rollback. It's very good, right? Now, some of the tools are like external tools like Terraform, Pulumi, Ansible, but some are like a cloud-based one, like a CloudFormation, Azure templates, and all. Now, these are like for the development thing. It's okay. Just ignore for now. So these all are a part of the DevOps, part of the application deployment. We know several components and phases involved. Now we talk about Ansible automation platform. So Ansible automation platform is kind of is a simple, but it's a powerful product to automate most of, I will say, all of our IT and application infrastructure components. It can be cloud, it can be database, it can be your private or public cloud, your host like Linux, Windows, X, whatever the operating system versions. Then it can be your network devices like switches, firewalls, like Palo Alto, Cisco, FortiGate, any network devices. Then it can be your like your container platforms like Kubernetes, OpenShift. You can use Ansible to automate every operations. That's a beauty of Ansible automation platform, and you don't need an agent to be installed on the host. Okay, now if you are already familiar with the picture, let me explain again. Here, these are the very high level components or overview of the Red Hat Ansible automation platform, where you have uh, the main UI, and now it's not calling Tower anymore. Sorry for that. I couldn't find a correct picture here. It's called Ansible Ansible Navigator. Sorry, Ansible Controller, where you have the GUI, where you can access the entire controller, the controller interface from the web browser. You don't need to deploy any application. Then you have Ansible Engine, which is the Ansible Core, which is part of the Ansible automation platform. And you have some other cloud services like Automation Hub, Analytics like Insight. Then it will control all the infrastructure like network, security, cloud, Windows, Linux platforms. Now, if we talk about the latest Ansible one, because I mentioned Tower because many know, okay, Tower was the old name for automation controller. Now we call it automation controller. Then we have execution environment, which is a Python based container images. Then you have automation mesh for automating and scaling your automation landscape to the different areas or different zones or different locations. So we are not going in detail because it needs a lot of time. Then we have also some tools for analytics like Ansible automation service catalog, and also the Insight. Insight will collect the automation details or job details and propose you, okay, what you can do or what you can do in terms of increasing the efficiency or how much you can save in terms of time and all. Okay, and this is a high level overview of the components of Ansible automation platform. Actually, we have like more than 17 open source projects behind this Ansible automation platform, and these all are open source. Anyone can access and install by themselves. Like you can install the Ansible builder just like using the DNF install or the pip install. Ansible Navigator you can install using the pip or DNF or yum. Then the automation control is the Tower, or you call the Ansible AWS, is again open source. So most of them are open source. Not most, actually, all of them are open source. Sorry for that. And you have also a Microsoft VS Code plugin, which will help you to configure your development, or because IDE, right? With the plugin. So it is a featureful one with auto completion, help on the screen kind of thing. Now, this is the very base or core of the Ansible, which is called Ansible Core. Earlier it was called Ansible Core, then we call it Ansible Base. Now it's called Ansible Core. Okay, this is the main building block of Ansible. This is a real Ansible. So this Ansible Core will take the YAML-based Ansible playbooks and will execute the task based on the module. So you can see on the screen, it's very simple module, simple playbook where you are installing something like, okay, copying some files, then you are creating some directory, installing packages. This is the beauty of Ansible. You don't need to learn any programming language to automate Ansible or develop the playbooks, because it's all YAML. YAML, you're already familiar with the YAML, I believe. Like you are using the YAML format for the Kubernetes, OpenShift, and all other DevOps tools. And anyone can read and understand, okay, what this playbook is doing. So you don't need any special skill to understand this. And most of the resources are available as open source, and you can download it and use it without paying for it, like no subscription fee, nothing actually. So you pay nothing for the open source and the community based roles, and playbooks. Another things at all is a human readable, and this is a good thing because you can share this content. Let's say you develop some playbook or some Ansible automation content which you think, okay, it will be useful for the community. Okay, contribute it. You can contribute this playbook and roles via Ansible Galaxy. That's all because collaboration. So maybe when I use that, okay, I saw, okay, this code I can improve by adding or changing something, then I can put it back. That's called open source development, right? Now, the good thing about Ansible is the pluggable architecture. So you can add any number of or any kind of modules to the Ansible. Like you can see, we are using a copy module, we are using a file module. Let's say we don't have a module available. These are simple scripts. You can use your own language like Python or something and develop your own module and contribute it. Or you can use the standard shell commands or the CLI commands. Now, the question is where I can use Ansible for automating in DevOps. You can use Ansible automation platform in actually most of the phases actually, but the best practice is very simple. Use the right tools at the right place, right? You can use Ansible for building the application, scanning the application, testing the application, merging. Yes, you can use it. Also, you can use Ansible for continuous delivery, like storing the images to somewhere in the container or storing the artifacts to somewhere kind of thing. Also, you can use Ansible for deploying the application to the production system. Okay, now in our case, we are talking about a lot of tools in DevOps, CI/CD kind of area. Okay, I just put few logos like well-known logos or well-known tools here. We are talking about two-way automation. You can use the tools to call Ansible to do something. And also you can use Ansible to configure and execute some on the tools. This is a two-way automation. Okay, you can use Ansible. For example, Jenkins want to do something which you cannot use simply Jenkins bash script or some commands because that's not flexible. You know, it's like a shell script or shell commands. Instead, you want to use Ansible playbook and you don't want to keep the credential in a Jenkins. You can keep the credential in Ansible automation platform, which is safe, which is encrypted also. And Jenkins will just trigger and tell Ansible, okay, do this, deploy this, or something like that. Also, Ansible can talk to Jenkins or other tools to configure something, update something, create some pipelines, or that kind of operation. That's called two-way automation. Now, this is a very kind of a typical workflow here. The developer will push the code to repository, so there will be like code review or code review, and someone will approve it, then merge it. So the merge can be automated, or merge can be happen when after the automated testing, right? So in our case, okay, it's in the Git repository, then it will trigger a CI/CD pipeline. So in the CI/CD pipeline, what will happen? The tools, for example, Jenkins here, will do the code merging, then it will do the scanning. It can be before or after, depending on your workflow. Test it, do the integration test, do the other tasks, and you can use Ansible for scanning. You can use Ansible for deploying, for most of the operations, or you can use Ansible to build the server, provision the new virtual machine, or install these applications like a Java or web servers, and finally deploy the latest version of application. So whenever there's a new change, again the same workflow will happen, and Ansible will take care of the deployment or whatever the operation you want. Okay, this is a very high level one, typical one. Now, this is kind of a theory part. Now we will have a demo based on the workflow we were discussing, how we can implement it and talk each other, like Jenkins can talk to Ansible and Ansible can talk to Jenkins. Okay. For the demo environment, it's simple. We will be using the similar items here. So we have a developer who will be using the VS Code as the IDE. Then we will have Gitty. Gitty is like a GitHub or GitLab is a very lightweight version control or source code management software. Then we have Jenkins as a CI/CD tool here. Then you have an API. So Jenkins will call API on automation controller and trigger some automation job, and automation controller will take care of the deployment, building the application and all. Okay. Let me switch my screen here. Okay. Now, so this is a challenge summary. So we will be testing some CI/CD workflow here. So the first thing, we have a lab, very simple lab where we have VS Code, then we have a Git, I mentioned as a repository one. Then we have a Jenkins running here. Okay, let me log in. Then we have a Ansible automation platform. Now, the VS Code, we can see this is like I am not sure it's visible. Let me know if it's not visible. Okay, so here we have the playbooks for the automation, like let's say configure Jenkins. So I have a playbook to create something on the Jenkins side. Then I have a playbook to release the application. So you can see it's using some URI module and calling some API. Then I have a playbook for deploying the application. So these are like, I have some playbooks, and also I have an application directory here where I can see some repository for the application. If I check here, you can see all the Python code here. This is a Python-based application. So Git, this is the same folder you can see here. Then we have a Jenkins as a pipeline, but no build started. The controller is here, and we have something configured. Now, what we will do? First task is to sorry. Yeah. So the first task is to change the pipeline, because right now, if you check, if you're familiar with the Jenkins, I have a pipeline already configured, and I have some stages and steps here, right? So it's saying, okay, getting the code, installing some packages. You can see it's a Python 3, and it's installing the requirement and dependencies. Then you have a static code checking using Python. Then you have using the Python lint actually, build tag. So it will build and push the software to the repository, I mean the Git one. Then you have, some kind of stages here. Now, if you check actually we don't have any deployment kind of operations here in the pipeline. You can edit here and save it. That's one way. But we want to automate this process, right? Maybe something goes wrong, or you want to, you want everything in the code. Instead of someone change it, you want to automate the pipeline as well. So what we have is the controller, and we have a job template configured to configure the Jenkins job. What I have to do is just simply launch the template. Then Ansible automation platform will talk to Jenkins over API and configure this pipeline for us. Let's wait for the job to finish. You can see here. Okay, let me go back. Wait for the jobs to finish. So now we are talking from Ansible to the Jenkins server. So it says, okay, job completed. Now we go and check the pipeline again. Okay, there is an additional stage now, which is calling the Ansible tower. Ansible tower means Ansible automation controller. And it says this is my tower and this workflow. Okay, I need to execute a job template called DevOps workflow. So if you check the template, there is a DevOps workflow job template. So Jenkins is saying, okay, as a last step, this job template should be executed. And inside the job template, there is a workflow actually. It will contain a lot of steps, kind of a building and all. Let me show that here. So this is a workflow here. You can see, okay, it's deploying to prod, then creating the release, then configuring the web servers in parallel, then deploy the application. Okay, great. Now we have pipeline configured automatically without any manual work. other than the automated configurations here. Okay, that's good. Now we check and proceed with the next task, which is update in the application, because now the application is not deployed anywhere, right? Okay, wait for that. Okay, now it says, okay, this is our let's use application, very simple some web page, but it says, okay, the service is not able to connect or no service available because the application is not deployed yet. So what you have to do is, first thing, this is the our application source code. We have to change something. Then only the workflow will trigger, right? Because in the Jenkins, sorry, in the Git, if you check the settings, we have a webhook already configured. So whenever there is a change in the code, this webhook will be triggered. That means our Jenkins pipeline will be triggered. Now I'm going to change something here. So I go to the templates, queues, and I change the home.html. So I want to change this. Okay, this is a line we have to change. So what I'm going to do, I just copy the text, paste the new line, I save it. What will happen, because the VS Code is already integrated with your source control management, it will show the change here. Okay, you change something on the code. Now we have to push this update. Okay, we have to push these changes to the Git repository, but you can do it in the command line way or anywhere, like a git push, git commit kind of thing. I'm just using the GUI based buttons here. That's it. I think the changes and go to the Git and Git. I check the repo. I can see there is a change a few seconds ago. Now we go to the Jenkins and see anything happened, because as per the configuration, if something was changed, something changed, the Jenkins pipeline will be triggered, and yes, we can see a pipeline already triggered here. Okay, so this is the automated pipeline here. We have it's just doing the pipeline. We have created the, like, getting the code, installing packages, doing the code checking, like code scanning, and it will also do the last stage we added, which is the automated task from the automation controller. Wait for that. So these are like we just updated the VS Code only. Now it says, okay, this installing package, static code analysis, all done, all good. Okay, it's pending somewhere in the DevOps controller DevOps phase, and it's still like it's going on. So if you check the logs here, uh, open this one here. We check the console output, we can see this code is doing something. Maybe it's a workflow which is running on the automation controller, Ansible automation controller. So what we will do, we have to check the Ansible automation controller and see what is happening there, because it's running for a long time and why it's not finishing, right? So if you check the automation controller, actually we have a approval stage here, because we are deploying to the production, right? So here you have a development happened, VS Code, you developed, then Git, you pushed, then Jenkins trigger the job. Now it's under the automation controller. Because you are deploying the application to production, we just included an approval phase. This is not really like mandatory. You can just make it like automated without an approval. But you know the ITSM flow or formalities where you have to approve the changes or approve some deployment to the production. So you can include that in the automation controller. Okay, now we go and check why it's not completed. So we go to the automation controller, and I can see there's a notification. It says deploying to production, because it's just pending here. I have to approve the workflow. Once I approve the workflow, what will happen? This workflow will be started, and you can see, okay, it's passed and it's doing two or multiple jobs in parallel. So once it's done, it will go to the deployment of the Acme application. good now, right? Okay, you can wait for the jobs to finish because it's doing a lot of things in parallel. Now, if you check the Git here, you can see the CI/CD pipeline actually already built some application. This is like a software called software, the CI/CD, the continuous delivery. The code is ready to deploy. So in our case, we didn't use any other repository. Instead, we use this release in your repository itself, like as a release. So your software code is like a 2.52.0 is here available and as a zip format, tar format. Yeah. Now we go back to the controller and see all successful. Now we go back and check the Jenkins job, all successful. Good, right? Now we check the let's queues again. The application is available. This is the good thing. So here we have used automation controller to configure the Jenkins like any CI/CD tool, and also we use um, automation controller for triggering a job from your CI/CD or DevOps workflow, like Jenkins, or it can be GitHub Actions, it can be anything. Okay. Yeah, this is a very like quick demo for the CI/CD one. So if I do some more changes, for example, if I want to change something again, the same workflow will happen again. Still, I have to approve the workflow because the workflow is part of the kind of the approval is part of the workflow because you are deploying to a production, so you must be careful, right? Yeah, you can skip that if you want. Depends on your environment. Now, this is our full workflow now. So we have edited the code or something changed in the code. It automatically triggered the workflow because there was a change in the repository. So even the changes you can control. Okay, you want to trigger the pipeline on what changes you can configure that. So if you go to the git key and webhook, you can decide you want to trigger the call or trigger this workflow for all events or only the push, only the create, only the merge. You can control this here and depends on the Git tool like GitLab or GitHub. There might be more or less features here. Okay, and here we have a new application because Ansible already created a new release and kind of thing. Okay, this is great. Now, if I change something else again, it will do the same workflow again. Okay. Yeah, that's a very high level demo for the CI/CD and how you can integrate Ansible within your DevOps workflow. It can be any stages, build or CI/CD or the continuous deployment, scanning, yeah, anything. And yes, that's it from my side. And I think we can take some questions or clarify if you have anything. Yeah, Suraj.
Thank you, Kinesh, for the session, and it was wonderful. If you guys have any questions, drop it in the chat box. I think there were two questions from yeah,
Uh,
Sarkar, some like in the chat
I
box. Yeah.
I cannot see the chat box here. I'm not sure
Oh,
something wrong with the application.
oh, can you like uh
This
maybe
issue with the Teams, I believe, because I didn't log
are
in.
you oh guess that might be the problem. Like
Yeah,
Teams not giving that to a
see, I cannot
possible.
log in with that one, so I cannot see the chat, I believe.
Maybe I can share my screen
Oh, that's
to
good. That's good. Yeah, I will stop sharing here.
can you see the chat?
Yes, I can see. Okay. Okay. So if you use Jenkins for automatic deployment, then how to use Ansible for same work? Okay. You can use Jenkins stages or steps, and actually you are executing some bash or shell commands. Um, so if you are using the shell or bash, you know the pain. Like you don't have much control on. Okay, you execute the command, you don't know it's a success or failed. um, like you deploy something, you just use like a yum install some package or pip install something, but maybe due to some issue the command failed. Then you blindly we have the next step to do something else. So what will happen? It won't be successful, and we don't know, we don't have much control whether it's a pipeline break or not. So that's why we use something more flexible one like Ansible. So Ansible, you can use a playbook. Inside the playbook, you can execute the task like installing the package or copying some files or checking some permissions and take the output. Then based on the output, you can decide the next action. This kind of workflow can be, it's very flexible when you use Ansible. Like you can use other shell script again, but Ansible is very flexible to do almost of your operation, because it means for configuring the environment and configuring the application. Yeah. So it's like still is a Jenkins, but instead of you just call the bash, you just call Ansible. You just offload the job of deploying a kind of a like a 10 step task to Ansible and say, okay, please do this. So Ansible will take care of it in a well word. And also one more thing, Ansible is idempotent, right? So idempotent means you ask to install some package. If you are using the shell, let's say you want to copy some files or something. So if you are using this cp command or something like whatever the command, it will just overwrite again and again. But in the case of Ansible, Ansible will check whether the file already exists. Like if the desired stage is already there, Ansible will not execute the task again. So you can execute the same playbook or same workflow again and again, but it will be difficult on the Jenkins, because Jenkins is blindly do the actual stage without checking, or you should have validations inside your Jenkins stage or step as a bash. Yeah. Hope it's clear, or otherwise please ask. Um, yeah, I think so. I can see Sagar already reply. Yeah, thanks. Yeah, it's like not replacing, it's just like combining. So use the right tool at the right place. Even you can use Ansible for the workflows like creating this A, B, C, D, but Jenkins do that job better. Jenkins or any kind of CI/CD tool will do that job better. So we use the right tool at the right place. That's a combination. Do you have the installation steps for an automation controller? Also the integration of Git, Jenkins? Yes, I can share that with Sudak later. Hopefully you will have some chat, I believe. I will share with Sudak later. Yeah, will do. On what type of project management or IT department can we DevOps STLC model be used? I will say any type of, right, because now we just talk about the DevOps, where we have a software code and deploy to the production. What if I'm a network engineer? So I have thousands of network devices where I want to change the configuration. For example, I'm creating a new VLAN. I want to deploy this new VLAN on 100 servers, because all 100 servers part of the same network, and I want to deploy this new VLAN and configure the some of the interfaces. So if I'm doing it manually or using some commands, then I have to log into all of these and do the same steps and make sure it's all working. You can use Ansible for these by putting this configuration as a code. So we call it, you can call it a NetOps or whatever the name, but yeah, it's a kind of thing. So you put like like your Terraform code or like your Ansible code. You put the configuration of the network as a code. Ansible will read the code and apply this. So whenever there is a change, for example, I created a new VLAN in my configuration and push to the Git server. So there is a change in the repository. So you can use a Jenkins or any kind of a CI/CD. So Jenkins will do the same job. It's not software code now; it's a network code, and you should have a tool to detect this network code, scan this network code, ensure it's good, ensure the policies are met like if there is a port open, then the policy you can apply. Okay, this code is wrong, cannot use in production, or this code is not is vulnerable. That kind of scanning you can include in the Jenkins. We are talking about network code again. And finally, you can use this code, pass to Ansible, and Ansible will implement the new VLAN on the target devices. 10, 100, or 1000. So you can use it anywhere. Like a storage, you want to provision it, you can use Ansible. You want to use like creating the virtual machine, yes, you can use it. Yeah. Yes, you can. So it won't call DevOps. It can be NetOps, some codes like a GitOps, some code like a DevSecOps. Yeah, it's like it's a culture and the tool collaboration kind of thing. Um, because all time we used to call, okay, I prepare the server and now it's your server. You can do whatever you want. Then the developer say, okay, this package is not available. The storage is not accessible. Then you say, okay, that's storage team responsibility. Or you say, okay, you check with the network kind of. That should not happen anymore. That's the main thing, right? Because you are provisioning the server for a purpose. So if the developer cannot use the server for deploying the application, then why they don't need you, right? That's a concept. So make sure the component you provision, or make sure the IT component you are provisioning is useful for the other one. So you should have a kind of a clear communication on terms of like what is the requirement and whether is really useful for the end user kind of thing. Yeah. So you can apply anywhere. Yeah. To be honest. Okay. Next question. It's clear, I hope. Let me know otherwise. I am a student. I'm completed RCSA and RCE. What is the best for next? Okay, RCSA and RCE, I believe you are already know Linux and Ansible. What is next depends on your interest. If you want to go for the Linux track, I'm not a career advisor again. You can go for the advanced Ansible course. There are multiple courses like an advanced Ansible network, and also for the Windows kind of tracks are there. You can try that, but if you think just like you want to know the infra side plus the container, then you have to go for the other track, because it's not mandatory that you should complete all the Ansible courses, then only you will be an Ansible expert. No, you know Ansible, then you just start working on the projects. That means not wait for the public someone to share the projects. Just check in the groups, Stack Overflow, whatever the Ansible community groups, you will see a lot of problems people are sharing. Okay, they are trying on these and it's not working, how to resolve it. That's a use case, that's a real-time project. So you know what they are doing. If it's just our workplace, we may be using only one or two use cases, but in the community you can see thousands of use cases. That's how I learn. Yeah. Is there any certification for Red Hat Ansible automation? Yes, there are multiple certifications from Ansible. Um, so the base is like you should know the Linux, and the other one is a 294, which is our Red Hat certified engineer. It's also an Ansible course. But if you want to complete that EX294, you should complete EX200, which is RSCSA. Then only you will get the certification as a system administrator and as a system engineer. So yeah, Red Hat certified engineer. And maybe I can share something. Let me check here. Let me check if I can share some slide. Um, okay, give me a second. I will just flash one slide here if I have. Okay. Last question is about the slide, right? Yes, I will share the slide for sure. After Sudhak stop sharing, I will share my slide and you can see that slide I will share. I will share with the Sudhak and hopefully you can distribute. It's not an issue. Certificates, I will flash the slide here once the stop sharing. I will share here. Any other questions before we switch the screen? Okay, if no other questions, I can share my screen. Give me a second. Let me know if you can see my screen here.
Yes.
Okay, so this is a high level one. Is a kind of a certification path for Ansible. So you have this RSCSA, which is a EX200 exam. then you can actually, it's not really a mandatory earlier, but now, if you want to be like RSCE, which is a EX294, then you should complete this before or after. Then only you will get the certification, because it's a RSCE SA and RSCE. So this is not Ansible. This is like a system administration, a pure Red Hat Enterprise Linux topic. Then you have this is the Ansible one. You can see that even the title is Red Hat Linux Automation with Ansible. Then you can go for the advanced one after the RSCE. And okay, these courses are like, you don't need to complete RSCE. You can, if you know Ansible, you can directly go for the courses. Like if you want to know more about the automation with the Red Hat Ansible automation platform, which I just explained, yeah, you have a course called DOS 374, and also we have exam. In the Ansible course, you will not explore a lot on the automation platform, but this course you will learn a lot. Then you have a course for the 374, which is like more developing the playbooks and best practice kind of thing. Then you have something for 47, which is a enterprise automation with it looks similar, but it's a different course. And there is an exam also. Also, you have a Windows track, and also we have another network track. If someone is from the network track and they want to learn Ansible for network automation, then they can select that course. So this specialization, you can just directly go for the specialization without RSE, but it's recommended, because if you don't know Ansible and if you're going for the specialization, yeah, it will be a bit difficult, right? So up to the uh, learner, right? If you're confident, you can go to the specialist course. Sorry, specialist course and exam directly. Hope this is clear. If anything, any question, yeah, you can ping me anytime on LinkedIn or somewhere. I can share more details, and yeah. Any other questions? Otherwise, yeah, we are good on time, I think.
Yeah.
Yeah.
If
So
you guys have a questions, please do post in the chat box. So it
yeah,
doesn't have to be like you guys have him here, so it is best time to be asking. So
yeah, just as yeah. Let me know if anything in the chat. Yeah. So if you are looking for any resources or learning material, or learning material or something, let me know, or just inform so that we can arrange. I can share the links or all the details so you can use it. Mm, yeah, I think that's all from my side. If no other questions, I'm good here, and hope it was a useful session.
yeah, there is no other questions. I think we can wind up for this. I think it was really helpful for all the attendees here, and looking forward to have more events with you. Thank you.
Okay, thank you all. Have a good weekend. Bye.